Hi friends, welcome to Sri Chaitanya. This is Umasankar, All India IT Coordinator. So far, we have successfully completed 4 lessons in vector algebra. Already I mentioned, immediately after complex numbers, we have started the vector algebra because there are some interlinked concepts between vector algebra and complex numbers. These two chapters are very, very important, especially for JEE Mains and Advanced examinations. Actually, first 6 lessons I have completely concentrated on properties of vectors. This is lesson number 5. And in till lesson number 4, in the first 2 lessons I have given the basic definitions and notations of the vectors and how to add the vectors and how to subtract vectors, what is a unit vector and what is magnitude of the vector and what are the direction cosines and conditions for collinearity, coplanarity, like that points that we have discussed, and moreover angle between the 2 vectors. And with the help of the basic definitions of the vectors itself, we have established some of the geometry results with respect to vector algebra. Now, this is about lesson number 5. Through this lesson, we are concentrating some more another problems on the vectors, vector algebra based on the properties of vectors. And my friends, please don't forget to check the description. There I am providing all the important links of the previous videos and if possible some of the good assignments and question papers for you, for your benefit. Now, through this lesson, here we are concentrating problems based on collinearity of the vectors, and what problems? Problems based on coplanarity of the vector, problems based on linear dependence and independence of the vectors. This is very, very important lesson. 99% one problem is guaranteed from this area. Directly or indirectly, they may give questions exclusively from this particular arena in vector algebra. And of course, here we are solving some of the questions only. Later classes, once after getting the complete awareness on the vector algebra, we will solve some of the mixed oriented problems also. Here, I am solving very basic problems only. And though they are basic, but they are very, very important. Okay. First, I am establishing and I am giving the confidence, I am giving the what is the behavior of the collinear and coplanarity vectors and which kind of problems, simple problems that they may ask in competitive examination, that part only here I am covering through this lesson. So, okay, my friends, see, now this is first question. If A bar and B bar are 2 collinear vectors, then which of the following is or correct? Is all are incorrect. So, my friends, this kind of options sometimes they may ask in competitive examinations. So, read all options very carefully. What they mentioned, which of the following is incorrect or incorrect. So, if only one is incorrect, then it is. If it is more than one, it is or. But here they are not asking you to find correct option. They need to ask or they need to find incorrect answers. So, read the options very carefully. What is given? A and B bar are 2 collinear vectors. If you are good at the definition of the collinear vectors, solving the problem is very easy. So, read the first option. One vector B bar is equal to lambda A bar. Yes, this is correct. Yeah, this is the definition of the collinear. There is no problem at all. But if A bar and B bar are 2 collinear vectors, not necessary that A bar is always equal to plus or minus B bar. That is why. Maybe, but what is given? A bar is equal to plus or minus B bar. It makes compulsory. But it is not compulsory. It may be. So, that is why since it is not authentic in all directions. So, this answer is not correct. And move to third point. The respective components of A bar and B bar are proportional. The respective components means component of suppose if in A bar I component is proportional to the I component of B bar and I component of J bar is equal to proportional to I component of J component of B bar, K component of A bar is proportional to K component of what is called B bar, like that they are asking. Yeah, if they are proportional, that means suppose if A bar is equal to A1I plus A2J plus A3K and B bar equal to B1i plus B2j plus B3k. If these two vectors are collinear, so as per definition, one vector is scalar multiple of another vector. So A1i plus A2j plus A3k equal to lambda times B1i plus B2j plus B3k. So here A1 is equal to lambda B1, A2 is equal to lambda B2, so A3 is equal to lambda B3. So what I am going to say is A1 by B1 equal to A2 by B2 equal to A3 by B3 equal to what? Lambda. They are proportional. Yeah, absolutely, this is right. Whereas fourth one, both the A bar and B bar have same direction but different magnitude. If they have same direction with different magnitude, they need not be collinear. They need not be collinear. So this is again wrong option. So among four, what are the incorrect answers? Second and fourth. See my friends, this is very, very elementary question based on, they have constructed the question based on the definition of the collinearity of the vectors. Like that, take all the definitions from our first lesson, you imagine what kind of questions they may ask or we can expect in competitive examinations. If you are thorough with this kind of problems, then problems becomes very easy for you. Now, coming to next question. If the points capital A, points are given, be careful. In vector algebra, you need to study from the problem whether they have given points or position vectors or vectors, something like that. Here what is given? The points are given, A, B, C are given. They are collinear. What they said? They are collinear. Then you need to find alpha and beta. You need to find alpha and beta. There are several methods, my friends. There are several methods. Whenever this kind of points are given for you, my suggestion would be, you do like this. You consider O as origin, then position vector of the first point is OA bar, that is 2i plus beta j plus 3k, and position vector of the second point is OB bar, that is alpha I minus 5j plus k. OC bar is equal to minus I plus 11j plus 9k. These are what position vectors of the 3 points. What they given? The points are collinear. Whenever points are collinear, see, suppose this is point A, this is point B, this is point C. So what I am doing is now establish two vectors, AB bar and AC bar. Try to understand these two vectors have the same what initial point. So what is my AB bar? AB bar equal to OB bar minus OA bar. That is what? Alpha minus 2 into I. This is my plus minus 5 minus beta j plus minus 2k. This is AB bar. What is AC bar? AC bar is equal to OC bar minus OA bar. That is minus 3i plus 11 minus beta j, and this is plus 6k. If these two are collinear, as per definition of collinearity, one can be expressed as some scalar multiple of next. So AB bar is equal to lambda AC bar. So AB bar is equal to lambda AC bar means alpha minus 2 into I minus 5 plus beta j minus 2k equal to lambda into minus 3i plus 11 minus beta j plus 6k. You write like this. Now what to do? You compare the corresponding ijk coefficients. Thereby you will get alpha minus 2 equal to minus 3 lambda and minus 5 minus beta equal to what? 11 minus beta lambda into lambda. and minus 2 equal to directly 6 lambda. So, my lambda is what? Minus 1 by 3. Simple, I got my lambda. Now, you substitute the values of lambda here, you will find alpha, beta, you will get the answer. This is the procedure. So, here whatever it may be the problem of this kind, whenever points are given and they are said to be collinear, you consider O as origin and find any two coinitial vectors, whether it is AB bar or AC bar or BA bar or BC bar or CA bar or CB bar, whatever it may, find any two vectors and apply the funda of definition, then equate them and solve all the three equations. See, the same thing here I have mentioned like this, the same thing here I have mentioned like this. Okay. So, see my friends, A, B, C are collinear, A, B bar and AC bar are collinear, lambda A, B bar equal to lambda A, C bar, just I am giving the hints. So, equate all the things, you will get lambda, alpha as, beta as like this. Okay my friends, this is the procedure. Actually in previous I have explained in detail. So, by taking this as hint, solve the problem on your own. Now, coming to the next question, here also read the problem. D bar is equal to alpha A bar plus beta B bar plus gamma C bar. That means the vector D bar is expressed as a linear combination of A bar, B bar, C bar. So, this is the vector, it can be expressed as a linear combination of A bar, B bar, C bar. Of that A bar is given, B bar is given, C bar is given, D bar is given, then they are asking to find alpha, beta, gamma. Okay. Okay. So, what I am doing is, what is given? D bar is equal to 3i plus 2j plus 5k. This is given. D bar is equal to alpha A bar, T bar equal to alpha A bar plus beta B bar plus gamma C bar implies 3i plus 2j plus 5k equal to alpha into what is A bar? My A bar is 2i minus j plus k plus beta into what is my B bar? I plus 3j minus k plus gamma into what is my C bar? Minus 2i plus j minus 3k. Now, what I am doing is, now compare I, j, k coefficients on both sides. Here 3 equal to, here it is what, 2 alpha and plus beta and minus 2 gamma. You call this as equation number 1. Similarly, j coefficient 2 equal to, here minus alpha and plus 3 beta plus gamma. You call this as equation number 2. And k coefficients 5 equal to, this is alpha, next minus beta and this is minus 3 gamma. Now, in your hand there are 3 equations, very simple. Add these two, that means alpha gets cancelled, and similarly you multiply this with 2 and add these two, again alpha will gets cancelled. You will get 2 equations in terms of beta and gamma, solve beta and gamma and find alpha, that is all. So, this is the traditional method. Okay? Yeah, the same thing here I am giving as a hint. After solving that, you will get alpha as minus 3 by 2, beta as 1 and gamma as minus 5 by 2. My friends, here I am not giving the detailed solution because it wastes of time for me, but I have given the hint beyond this, and based on that you utilize the previous slide, I mean previous explanation, and solve and put everything on paper and you will get the answer very clearly. Finally, you should get alpha as minus 3 by 2, beta as 1 and gamma as what? Minus 5 by 2. Okay? Now, coming to problem number 4. Yeah. Show that the points A, B, C, again here points are given. They are collinear. Find the ratio in which B divides AC. See, it is also just like previous model, but here again they added some extra thing. So, we need to find B which divides AC. So, there are several methods to solve this problem, but my suggestion would be, if they are giving some added information like this, we need to find some added information like this. Better suggestion is you find all the distances very carefully. That means you find AB, AC, AB, BC, CA, and with the help of those magnitudes, you will understand that okay, sum of any two things is equal to the next one. So let us see. Suppose let O be the origin. Whenever point is given, then immediately let O be the origin. Therefore, OA bar equal to what? I minus 2j minus 8k. OB bar, that is what? 5i minus 2k. OC bar, that is equal to 11i plus 3j plus 7k. These are my OA bar, OB bar, OC bar. Now find AB bar. AB bar. What is AB bar? OB bar minus OC bar. What is OB bar minus OC bar? That is 4i plus 2j and plus 6k. Find AB, that is magnitude, that is root of 16 plus 4 plus 36. So this is 40, 56, root 56. So this I can write it as 56, that is 4 ones, 4 fours. Yeah, 2 root 7, this is 2 root 7. Find AB bar, AC bar or BC bar you can find. There is no problem for me. Better you find BC bar, no problem. Yeah. So BC bar, that is OC bar minus OB bar, that is 6i plus 3j plus 9k. Then what is my BC? Right, 36 plus 9 plus 81. So this is 90 plus 36, 90 plus 36, 6, 8, 9, 10, 11, 12, 126. 126. Again I can write this as 126 sevens, 7 ones, 7 eights, 9 twos. So this I can write it as again 3 root I think this is what 7 ones are 7, 57, sorry 52, 9 twos. Okay, 3 root 14, 3 root 14 I can write, or this I can write as 2 root 14, 2 root 14, 14, 2 root 14. This is 3 root 14. Similarly, you find CA bar, that is OA bar minus OC bar. OA bar minus OC bar means minus 10i. OA bar minus OC bar, that means minus 5j, and this is minus 15k. Okay. Then what is CA? CA again it is what? Root of 100 plus 25 plus 225. So 125 and 225. This is 10, this is 5, 3, 350, that is 14, this is 2 ones, 2 sevens, 2 fives, next 5 threes, 15, 5 fives, 7 fives. So this I can write it as 5 root 14, 5 root 14. So what I did, simply I have taken Y as origin and I found position vectors and I got AB, BC, CA. Why I am very much interested on finding AB, BC, CA? Because they need to find B divides CAC, the ratio at which B divides AC. So here it is very clear that what is my AB? Magnitude, not AB bar. What is my AB? That is 2 root 14. And what is my BC? That is what? 3 root 14. What is my AC or CA? Because there is no problem with the AB and AC, BC and CB, because they are magnitudes. So what is my AC? That is 5 root. So it is very clear that AB plus BC equal to AC. Now imagine what kind of platform or what kind of positions that point on a line. So if it is the line, since AC is, this is A, say this is B and this is C. So this AB is what, 2 root 14 and this is what, BC 3 root 14 and total is what? So automatically sum of two magnitudes is equal to third one, automatically according to triangle of addition again I can apply, or I can say the points are collinear. Moreover, from this diagram it is very clear that B divides AC in the ratio 2 root 14 is to 3 root 14, that is 2 is to 3. So whenever this kind of points are given and they need to find, they are asking you to find the point which divides the remaining 2 points, line segment joining 2 points, this is the best procedure. This is the best procedure. So my friends, again please try to understand all the points here. So here what I am doing is, next the same statement again also we can state like this. Show the 3 points A, B, C with the position vectors. Please try to understand the difference between these two. Both are same. Here in the above question I have given the 3 points, whereas the same question in another language, the 3 points with the position vectors like this, both are same, respectively collinear, you have to find B divides AC. So here what I did, I found method number 1. I found, just I mentioned, I got AB, BC, CA, and you please find AB bar you know, you find AB, and BC bar you know, you find BC magnitude, and AC bar you know, you find AC, and you will find that AB equal to 2 by 5 AC, you will get the answer. Therefore the points are collinear. This is method number 1. And method number 2, actually here they are not asking you to find the points or find the point which B divides AC or C divides AB or something like that. Just they need to find whether they are collinear or not. My suggestion would be, if the statement is like this, if the statement of the problem is like this, better is you find this determinant. This is shortcut way. Just if 3 points are given, points, be careful, they are not vectors. They are not vectors. If 3 vectors, more than 2 vectors are given for you, there is no right to talk about the collinearity. The question itself is wrong. We need to talk about only the coplanarity. So whenever more than 2 vectors are given for you, whenever 2 vectors are given, we need to talk whether the vectors are collinear or not collinear, whether the vectors are parallel or not parallel, whether the vectors are like vectors or unlike vectors. That is possible only when 2 vectors are given for you or 3 points are given for you. Please try to understand, whenever 3 points are given for you or whenever 2 vectors are given for you, we need to find, or one should find, or one should check whether the points or whether the vectors are collinear or not, or parallel or not. But no, please don't ask when 3 vectors are given for you and verify that whether they are collinear or not. If anybody is asking the question like that, the statement itself is wrong. So please don't apply the collinearity or checking the collinearity of collinearity for 3 vectors. That is for only 2 vectors. Okay, that's why. Since here 3 points are given and they are asking you to check whether they are collinear or not, either this is another second method. You just find the determinant and solve this, you will get answer 0. This is method number 2. But in addition to that, if anybody is asking find the ratio at which this point divides line segment, then only you adopt the method number 1. And of course, method number 3, this is again already I told better, this is another way. Of course, the same thing I have mentioned, we found, we got it. And my friends, actually here the important point is, we observe that AB bar plus BC bar plus CA bar equal to 0 bar. Once after finding AB bar, BA bar and CA bar in our previous problem, this problem, you just see, see my friends, actually here if you find AB, BC, CA, AB bar plus BC bar plus CA bar, 4i plus 6i, that is 10i, 10i plus 10i, that is what? 20i. So, AB bar plus BC bar plus CA bar, AC bar, CA bar, that means minus 10i. See my friends, AB bar plus BC bar plus CA bar equal to what? 0 bar you will get it. That is the beauty. This is AC bar man. CA bar means minus 10i minus 5j minus 15k. So, here what I am going to say is, read the statement properly. We observe that AB bar plus BC bar plus CA bar is equal to 0 bar, but points ABC do not form a triangle. Okay. Though sum of the vectors in this direction is 0 vector, but here the vectors, the points need not form a triangle. Okay. But this is the basic condition to establish for a triangle. If ABC is a triangle, then AB bar plus BC bar plus CA bar is equal to 0 bar. Please try to understand. If ABC is a triangle in a vector algebra, then AB bar plus BC bar plus CA bar equal to 0. But converse need not be true. That means whenever AB bar plus BC bar plus CA bar is equal to 0 bar, that does not mean that the points are always the vertices of the triangle. They may be collinear also. This is why this example will help you a lot in this direction. Okay, my friends. Now, here also same thing. See, show that the vectors, actually what is given? Show that the vectors A bar minus 2B bar plus 3C bar minus 2A bar plus 3B bar minus 4C bar minus B bar are coplanar. See, here 3 vectors are given. They never given 3 points. Okay, whenever 3 points are given, don't say that, don't check whether they are coplanar. That is the foolish thing. So, that is why please try to understand the language in the question. So, here 3 vectors are given. So, 3 or more, for more than 3 vectors, always we need to check for coplanarity. Because if 2 vectors alone are given, always they are coplanar. Already I have told, we discussed at that point in our previous video. So, whenever we are talking about 2 vectors are always what? Coplanar. No need, not necessary to discuss about coplanarity. That is a foolish thing. So, here 3 vectors are given and they want to show they are coplanar. Okay? Where A, B, C are there, here A bar, B bar, C bar are what? Non-coplanar vectors. That is again important. That is why while solving the problems before that, you please try to understand the statement. So, whenever this kind of question is given for you, again there are several ways. Actually, to prove coplanarity, here I am also introducing several methods. This is method number 1. You take 1 as this one and beta as this one and gamma as this one. You express any one of these 3 vectors as a linear combination of other 2. So, whenever 3 vectors are given for you and they are asking you to find whether they are coplanar or not, better is you take any one of them and express that as the linear combination of remaining 2. So, I have taken alpha and I have expressed alpha in terms of linear combination of beta and gamma, that is alpha bar is equal to xb bar plus y gamma bar. We need to find x and y. Okay. So, this is alpha bar, you take this x into this one plus y into y. After comparison of coefficients of a bar, b bar and c bar, you will get 3 equations. This is first equation, this is second equation and this is third equation. By just coefficients, by equating the coefficients, you will get 3 equations and you take the determinants of the 3 equations, I mean coefficient of x, y and this constant. You take the determinant and you find that this and you will identify that this determinant becomes 0, therefore, the vectors becomes what? Coplanar. This is one test. This is one test. So, that means what? This is the system of linear equation. Whenever a system of linear equations possesses a solution or inconsistent, or inconsistent, for that you take the determinant and if this determinant is 0, then automatically the system is inconsistent. That means it never possesses solution. That means the vectors becomes what? Coplanar. This is one method. Okay. Or another method is, say take alpha bar equal to like this, beta bar equal to like this, gamma bar equal to like this and take determinant directly determinant. This is 1 minus 2 3 coefficient of a bar, b bar, c bar and second vector this one and third vector this one. and you prove this as 0, therefore automatically this is coplanar. This is traditional method. Method number 2 is traditional method. Whenever 3 vectors are given for you, to check whether the vectors are coplanar or not, better is you find the determinant and show that this is 0. Again, we will discuss the same questions in our triple products, in vector triple products also, because the same thing we can also call it as a triple product of 3 vectors, that I will discuss later. But at present, with the help of the elementary knowledge only and based on the basic definition of the coplanarity only, I am introducing these particular methods. Okay? This is method number 2. Now, my friends, again, if the vectors are coplanar, another language, they are all linearly dependent. If vectors are non-coplanar, then the vectors are linearly independent. So, if they are asking to find linearly dependent or linearly independent, linearly dependent is nothing but the vectors are coplanar. LD means linearly dependent. Dependent. And this language, linearly dependent and linearly independent, one can use only for what? Vectors, not for points. One should use only for vectors, not for points. So, whenever the vectors are studied to be linearly dependent, you just prove whether they are coplanar or not. If they are coplanar, automatically they become LD, otherwise they are LI. And based on problems based on LI and LD also they may ask in competitive examinations. Of course, the same question they may ask. Actually, what is the statement? What is the statement? Here the statement is what? Show that the vectors are what? Coplanar. In the place of coplanar, sometimes show that the vectors are LD, linearly dependent. So, the same procedure you can adopt. The same procedure you can adopt. You find the determinant and prove that as 0. Okay, my friends? This is about collinearity and coplanarity and relation between coplanar and linearly dependent and linearly independent. Coplanar vectors are always what? Linearly dependent, and if vectors are not linearly dependent, then they are called linearly independent. But problems exclusively based on linearly independent and dependent, we will concentrate in the next lessons. Okay? Next. Now here, see the question very carefully. Here what is given? 4 points are given. Whenever 4 points are given, don't say that whether they are collinear or not. That is wrong statement. So here 4 points are given and you need to check whether they are coplanar or not. So here also what I am doing is, just like in our previous problem, here you need to find 3 coinitial vectors. Let O be the origin you take. So OA bar equal to, you take this as 2A bar plus 3B bar minus C bar, OB bar and equal to A bar minus 2B bar plus 3C bar, OC bar equal to minus OC bar equal to 3A bar plus 4B bar minus 2C bar, OD bar equal to A bar minus 6B bar plus 6C bar. You take like this and you find 3 vectors, coinitial vectors AB bar, AC bar, AD bar. See, or you can find BA bar, BC bar, BD bar, or CA bar, CB bar, CD bar. I am just applying the what? Definition of the coplanarity. Now, after getting this, AB bar means OB bar minus OA bar. OB bar minus OA bar means this is A bar minus 5B bar plus 4C bar, and AC bar, OC bar minus OA bar. That means A bar, this is plus B bar, and this is what? Minus C bar, and OD bar means AD bar means OD bar minus OA bar. That means minus A bar, and this is minus 9B bar and plus 7C bar. Now I got 3 vectors having same initial point. Find determinant. That means minus 1, minus 5, 4, 1, 1, minus 1, minus 1, minus 9, 7, and you solve this, you will get this as 0. Whenever it becomes 0, automatically the vectors AB bar, AC bar, AD bar are coplanar. Whenever AB bar, AC bar, AD bar are coplanar, the corresponding points are what? Coplanar. So again, here whenever 4 points are given, we need to check whether they are coplanar or not. And again, my friends, please don't say that whether they are linearly independent or dependent, because the term linearly independent and dependent applicable only when vectors are given. For points, it is not applicable. Be careful, because the definition itself contains in linear independence and dependence, the vectors are said to be linearly independent, the vectors are said to be linearly dependent. They never say that the points are said to be linearly independent, the points are said to be linearly dependent. That is why. Please try to understand the difference between the two. Okay. Here the same thing I am establishing, I am giving a sort of hints also for you. I am giving the hints for you. See, I am giving the hint for you. See, find alpha equal to AB bar, beta equal to AC bar, gamma is equal to AD bar, 3 co-initial vectors. Find determinant, you will find 0. Automatically the points are coplanar. This is one test. Okay. Now, my friends, if you like this video, please share and subscribe my channel, and please don't forget to press the bell icon, and we will meet with the next lesson in properties of vectors soon. Thank you very much.